Hello everybody, welcome into another lesson and welcome into a brand new unit. So today we are starting the unit on quadratic functions and their graphs. So here we have the function f of x equals x squared, the real most basic rudimentary quadratic function. Now you see the graph here, you get this nice little curve called a parabola for the graph of f of x equals x squared. Since the coefficient on x squared is positive, it's just a positive 1, it's going to open upward, which means to the left of the vertex it rises, to the right of the vertex it rises. So you can say that it rises both to the left and the right. The vertex itself is at 0, 0. So what is a vertex of a parabola? It's either the highest or the lowest point. If it opens upward, the vertex is your lowest point. It's 0, 0. The y value can't go any lower than 0 is what that means. To find, and then you have what's called the line of symmetry. The line of symmetry for this, for the basic f of x equals x squared, is right through x equals 0. So the line of symmetry will always be x equal to the x-coordinate of your vertex. The idea is with that line of symmetry, you could take each half of the parabola, fold it over top of each other, and they would fit evenly. And then to really graph it, what you want to do is take 2 points on either side of the line of symmetry. So you can, if you pick x equals 1, of course you'll get 1 because 1 to the second power is 1. If you pick x equals 2, you'll get 4 because 2 to the second power is 4. Then on to the left of x equals 0, if you pick x equals negative 1, you'll still get y equals positive 1 because negative 1 to the second power is positive 1. And then likewise with negative 2, if you take negative 2 to the second power, you'll get positive 4, thus generating this graph of the parabola which opens upward. Now, what if I made a minor adjustment here? I'm going to do that, okay? I'm going to do that. Let me get a marker. Help if I had the right marker. There we go. Alright, let's say this time I made f of x equal negative x squared. What if I did that? So f of x equals negative x squared, that's going to change a few things here. So if I put in 0, well, I'll still get 0 because the negative of 0 is 0. That's going to be my vertex. That hasn't changed. But what if, let's go through the line of symmetry, because the line of symmetry is still going to be x equals 0. That also hasn't changed, but let's find 2 points on either side. Let's say I put in positive 1. Well, 1 squared is going to be 1, but you have the negative sign on in front of that, so it'll turn into negative 1. So you'll have 1, negative 1. So 1 point you'll get is 1, negative 1. Now, how about if I put in 2? Well, 2 squared is 4, but the negative sign in front of that would make it negative 4. Alright, so we'll have 2, negative 4. Now let's go to the left of this line of symmetry. What if I put in x equals negative 1? Negative 1 to the second power is going to be positive 1, but you have the negative sign in front of that. It'll put it to the negative first. It'll put the y at negative 1. Then if I take, we'll have negative 1, negative 1. Then if I take x equal to negative 2, negative 2 to the second power is 4, but you got the negative sign in front of that. That would put you at negative 4 for your y coordinate. So you'll have the point negative 2, negative 4. So you're actually going to get the graph of it's still a parabola, but it opens downward this time. This one opens downward since you have a negative sign on the front of it. Now, if you go to either side of the vertex, it falls to both the left and the right side. So it falls to the left and to the right. So that's what a negative sign does. It flips it where it reflects in the x-axis. Notice the x-axis is like a mirror. It'll just reflect it over the x-axis. All right. Now a couple of general other things here. I'm going to do a couple of other things. What if I had f of x equals 2x squared? So this time f of x equals 2x squared. Well, take your 0. Your vertex is still at 0, 0. That hasn't changed. Now, your line of symmetry is still at x equals 0. So let's find two more points to the right. Let's find 2 points to the right of that line of symmetry of x equals 0. What if I put in x equals 1? 1 to the second power is 1, but times 2 on the front of it, that'll actually put you at 1, 2. So you have the point 1, 2, right? Now what if I put in x equals 2? Well, 2 to the second power is 4, then take that 2 times that, since you have a 2 on the front of it, that would actually put you all the way at 8. So you would have the point 2, 8. Now, let's go to the left of the line of symmetry. If I put in -1 for x, well, -1 to the second is still positive 1, but take that times 2, you'll end up getting positive 2. And then, if I go ahead and I take -2 for x, well, let me put that in here, you get -1, 2. If I take -2 to the second, that gives me 4, then take that times 2 on the front of it, that would give me also 8. So you would end up getting the point -2, 8. So let's see what this does to your graph here. Very interesting. So notice it seems to stretch it more vertically and shrink it horizontally. It's not as laid out horizontally, but it stretches it up more vertically. That 2 is called your a. A is some coefficient on your x squared term, okay? And a, if it's greater than 1, that means you have what's called a vertical stretch. This is a vertical stretch. And then if I have, it's also a horizontal shrink. And it's still going to open upward and all that, right? Okay, so now let's do something different here. What if I put 1/2 in front of the x squared? So the coefficient on x squared this time is going to be 1/2. What happens then? Well, the vertex hasn't changed. It's still at 0, 0, because if you put in 0, you're going to get 0. Half times 0 is 0. But what if my line of symmetry is still x equals 0, but what if this time I decide to put in x equals 1? So 1 squared is still 1, but times half, it'll only give you half. So you're going to be all the way over here. So you'll end up getting the point 1, 1/2. Now what if I put in x equals 2? Well, 2 squared is 4, times a half is 2. So 2 will put me at 2. So we'll end up getting the point 2, 2. So we found 2 points to the right of the line of symmetry. Let's try to find 2 points to the left of the line of symmetry. If I take -1, well, -1 squared is +1 times half. That would give you +1/2. So you'll end up having, let's see, -1, 1/2. Now what if I put in -2 for x? -2 to the second is +4 times half would give me 2. So you'll end up getting -2, 2. Now we can connect this. Notice what it did. It actually seemed to fatten your parabola. It fattens outward more. That's what's called a vertical shrink. That a, which is 1/2, so if a is less than 1, that becomes a vertical shrink because it doesn't stand up quite as much. It goes outward more. This is a vertical shrink, which would be a horizontal stretch. It's more stretched horizontally at that point. So that's what happens when you have any coefficient other than 1 on the x squared. Now, there are also 2 general forms of the equation for a function of x squared for a quadratic function to give you the graph of a parabola. So let's see, you have what's called the vertex form. Well, actually here you have the general form. The general form is going to be f of x is equal to ax squared plus bx plus c. That's the general form of a quadratic function. F of x equals ax squared plus bx plus c. Everyone should have seen this in Algebra 1. Now here it is again in Algebra 2. How would you go about finding your vertex in this? Your vertex, your x-coordinate is going to be at x equals negative of b over 2a. Alright? So to find the vertex, if it's in general form, you take negative of your b coefficient, which would be the coefficient on the x to the first term, divide that by 2 times your a coefficient on the x squared term. Then your y coordinate is simply going to be f of negative b over 2a. You'll take that negative b over 2a, you'll put that into the function and find the y value. So the coordinate, of course, would be negative b over 2a, f of negative b over 2a. That is the coordinate of your vertex. Now the line of symmetry, as I said, the line of symmetry is also the x-coordinate of your vertex. So the line of symmetry is going to be equal to x equals negative b over 2a. That would be your line of symmetry. So let's go ahead and graph a few of these in general form. Alright, so what do we got here? Let's say we have f of x is equal to x squared minus 2x minus 1. So we have x squared equals, f of x equals x squared minus 2x minus 1. So first thing you want to do is find your vertex. That, of course, for the x coordinate is going to be equal to the negative of b. Well, b is negative 2, so that'd be negative 2 is positive 2 over 2 times your a. The coefficient on the x squared term is your a, which is 1, so 1 times 2 is 2. That would give you an x coordinate of 1. Now to find your y coordinate, you just put in f of 1, which 1 squared is 1, minus 2 times 1, it's minus 2 minus 1. So 1 minus 2 is negative 1 minus 1 is negative 2. So you have a vertex, abbreviated v, at the point 1, negative 2. So your vertex is going to be at 1, negative 2. So there's your vertex. The line of symmetry is going to be x equals 1. The line of symmetry is always at the same equation where you have for your vertex. So for the x coordinate of the vertex. So the line of symmetry is at x equals 1. Now, to the right and to the left, we need to plot 2 points. So here's your vertex at 1, negative 2. Something else to note, if the coefficient on your x squared term is positive, in this case it's a positive 1, it's always going to open upward. So if a is greater than 0, which is the coefficient on your x squared term, it opens upward. If a is less than 0, which would mean it's negative, it opens downward. Alright, so what if we put in, let's do f of 2. That's probably a safe one to do. So x would equal 2 is what that means. So 2 to the second is 4. Minus 2 times 2, which is minus 4. Then minus 1. 4 minus 4 is 0, which would be negative 1. So you would end up getting the point 2, negative 1. Why don't we also put in f of 3? So 3 squared is 9, minus 2 times 3, which is 6, minus 1. Well, 9 minus 6 is 3, minus 1 is 2. So you'll end up getting the point 3, 2. So 3, 2 would go right here. All right. Now, what if I put in, let's go to the left of the line of symmetry of x equals 1. Let's put in f of 0. F of 0 is going to equal, see, 0 squared is 0, minus 2 times 0, which is 0, minus 1, which would equal negative 1. So you'll end up getting the point 0, negative 1, which would be right there. And then, of course, if let's say I put in f of negative 1. F of negative 1, so negative 1 squared is going to be positive 1. Minus 2 times negative 1, that's actually plus 2. minus 1. So let's see, 1 plus 2 is 3, minus 1 is 2. So you'll end up getting the point negative 1, 2. So negative 1, 2 rests right there. Now we have sufficient points to plot this parabola. So there you go. That's what your parabola would look like for f of x equals x squared minus 2x minus 1. So start by finding your vertex. The x-coordinate is going to be negative of b over 2a. In this case, ended up being 1. And then I'm just going to find my y-coordinate by taking that f of 1. I'll get my y-coordinate of the vertex, giving me a vertex at 1, negative 2. My line of symmetry is x equals the x-coordinate of the vertex, which x equals 1. And then I just plotted 2 more points to the right and to the left of the line of symmetry, and I came up with those points and was able to connect the curve. And remember, if that coefficient on x squared, which is your a, if it's greater than 0, which means it's positive, the parabola will open upward. If the coefficient on x squared were to be negative, which would be less than 0, your parabola opens downward. So I got plenty more where that came from. Let's just reconnect this a little bit here. All right, what's the next one here? Doozy. We have 2x squared minus 12x plus 19. So we have f of x equals 2x squared minus 12x plus 19. Well, is the coefficient on my x squared term, which is a, is that coefficient positive or negative? It's positive, so that means the parabola is definitely going to open upward. Now let's work on finding the vertex. The vertex, of course, x equals the negative of b over 2a. The b coefficient is negative 12, so if I negate negative 12, I'll get positive 12 over 2 times my a coefficient of 2. That'd be equal to 12 over 4, which would give me 3. So my x-coordinate is sitting at 3. Now, that also means my line of symmetry is at x equals 3. Because that's always the x-coordinate of my vertex is the line of symmetry at x equals 3. To find the y-coordinate, take f of 3. So, let's see. 3 to the second is what? That's 18 times, sorry, 3 to the second is 9 times 2, which is 18. Minus 12 times 3, so that's minus 36. Then you have plus the 19. So 18 minus 36 is negative 18 plus 9 is 1. So therefore I get a vertex then, my x-coordinate of 3, my y-coordinate of 1. So my vertex can be found at 3, 1. That's right there. Now, we've established a vertex is at 3, 1. It's going to open upward. Line of symmetry is at x equals 3. Let's find 2 more points on each side of the line of symmetry. So let's start with f of 4. We'll make x equal to 4. So 4 to the second is 16 times 2 is 32. Minus, all right, let's see, 12 times 4 is 48, so that'd be minus 48. Then all that plus 19. 32 minus 48 is negative 16, plus 19 is 3. So I end up getting the point 4, 3. So I got to plot 4, 3, which is going to be right there. And then for good measure, let's do f of 5. F of 5, okay, so 5 to the second is 25 times 2 is 50, minus 12 times 5, which would that be minus 60, then all that plus 19. So 50 minus 60 is negative 10 plus 19, that'd just be 9. So I'll end up getting the 0.59. So we'll plot, wow. That would go all the way up here. Okay. Now, why don't we plot f of 2? We'll go to the left of the line of symmetry. All right, f of 2. So 2 to the second is 4 times 2 is 8. Minus 12 times 2, that'd be minus 24. Then plus 19. 8 minus 24, that's going to be negative 16 plus 19, that'd be 3. So you'll end up getting the 0.23. So let's plot 2, 3 right here. And then why don't we plot f of 1? So let's see, 1 squared is 1 times 2 is just simply 2. Minus 12 times 1, that'd be minus 12. Then all that plus 19. 2 minus 12 is negative 10 plus 19 equals 9. So you'll end up with the 0.19. So let's plot 19, which would be right there. Now that you've got sufficient points, you can go ahead and connect the curve. It does eventually cross the y-axis. We don't want to draw this super big, but that's what the graph of f of x equals 2x squared minus 12x plus 19 would look like. Let's do a couple more for general form, then we'll move on to vertex form. Alright, good one. This time, negative x squared plus 4x minus 2. Alright, so f of x equals negative x squared plus 4x minus 2. Let's establish something first. Is the coefficient on your x squared term positive or negative? In this case, it's negative, so that means your parabola is going to open downward. It's going to actually go downward. Now, let's go ahead and find the vertex. So let's see. X would equal negative of b. Your b is positive 4, so that'd be negative 4 over 2 times your a, which is negative 1, which would give you negative 4 over negative 2, giving you your x coordinate at 2. Which means your line of symmetry is also at x equals 2. Because it's always what your x coordinates equal to. It'll be x equals 2. Now to find your y coordinate, just put in that f of 2. So let's see, 2 to the second power is going to be 4 times that negative 1 coefficient actually turns into negative 4, plus 4 times 2, which is 8, then minus 2. So negative 4 plus 8 is 4, minus 2 is 2. So you end up getting a vertex at the point 2, 2. So the vertex of this parabola is at 2, 2, which would be right here. There's your vertex. Now, let's plot 2 points on either side of the line of symmetry. So why don't we start with f of 3? So if I take f of 3, well, alright, so 3 to the second is 9 times negative 1, that becomes negative 9. Plus 4 times 3, that's going to be 12. Then minus that 2. So negative 9 plus 12 is 3, minus 2 is 1. So you'll end up with the point 3,1 as one of your points. You have 3,1 right here. Then for good measure, let's do f of 4. So alright, so 4 to the second is 16 times that -1. That gives you -16. Plus 4 times 4, which is 16. Then you just have the -2. Well, -16 plus 16 is 0. Minus 2 gives you -2. So you'll have the point 4, -2, which will go all the way over here. Alright, now let's go to the left of the line of symmetry. Why don't we put in f of 1? F of 1, alright, so 1 to the second is 1 times that -1 coefficient will give you -1 plus 4 times 1, which is 4, then minus 2. -1 plus 4 is 3, minus 2 is 1. So you'll end up with the point 1, 1. Then why don't we put in f of 0? F of 0, so 0 squared is 0, negate the 0, you just got plain old 0. Plus 4 times 0 is still 0. Then just minus 2. Well, this would just give you a value of -2. So you'll end up getting the coordinate 0, -2. So that would go right here. Now we have sufficient points to connect the curve. And there is your parabola. So we found the vertex to be at 2, 2, which means a line of symmetry is at x equals 2. Since the coefficient on the x squared term is negative, the parabola opens downward. And we just found 2 other points on either side of the axis of line of symmetry, and you got the points to connect the curve. Why don't we do one more of this form, then we'll move on to vertex form. All right. F of x equals -3x squared plus 5. So we just got f of x equals -3x squared plus 5. Well, what is the coefficient on our x squared term? Is it going to be positive or negative? It's negative, so that means your parabola once again will open downward. Now, we need to find, since we've ascertained that, let's find the vertex. So that means x equals negative of b over 2a. Notice you have no x to the first term, which would give you 0. So right away x equals 0, because 0 divided by anything is 0. So if I put in f of 0 now, that's going to be, of course, let's see, 0 squared is 0 times -3 is 0. Then you just have the plus 5. So the vertex would be at 0, 5. So the vertex would sit at the point 0, 5. And your line of symmetry is at x equals 0. So let's find 0, 5 here, which is right there. There's your vertex, and it's actually going to open downward since you have a negative coefficient on the x squared term. Line of symmetry is at x equals 0. Let's find 2 additional points to the right and to the left of the line of symmetry. Let's start to the right. So what if I put in f of 1? Alright, so f of 1, 1 to the second power is going to be 1 times -3 is -3, then plus 5, though that would give you 2. So you'll end up getting the point 1, 2. Here is 1, 2 right here. Now let's see, let's put in f of 2. So 2 to the second is going to be 4 times negative 3 is negative 12. Then just plus that 5. Well, let's see. So negative 12 plus 5 is negative 7. So you'll end up getting the point 2, negative 7. So come all the way over here. There's your 2, negative 7. Now let's go to the left of the line of symmetry. So put in f of negative 1. F of negative 1 is going to end up being, let's see, negative 1 to the second is positive 1 times negative 3 is negative 3. Then just plus that 5 would end up giving you 2. So you'll get the point negative 1, 2. So there's negative 1, 2 right there. And then let's put in f of negative 2. So negative 2 to the second is positive 4 times negative 3 is negative 12. Then just plus that 5. Negative 12 plus 5 is negative 7. So you'll get the point negative 2, negative 7, which is going to go right about there. Now there's sufficient points to connect your parabola. And there is your parabola that opens downward because of that negative coefficient on the x squared, vertex at 0, 5, and then your other points, line of symmetry, x equals 0. So that's the general form, how you would find it in general form. Now there's also a vertex form. There is a vertex form indeed. Which actually might save you just a little bit of work. Alright, so let's see, vertex form. Alright, so you have the vertex form of a quadratic equation where you have f of x equals a times a quantity of x minus h squared plus k. So that a is still your coefficient that indicates whether the parabola is going to open upward or downward. If the a is positive, the parabola opens upward. If it's negative, it opens downward. And then if you have an a that is greater than 1, if the absolute value of a is greater than 1, I should say, it indicates a vertical stretch. If the absolute value of a is less than 1, like you get a fraction for that coefficient, it indicates a vertical shrink. Now, you have the x minus h squared. The idea is, if you take x minus h squared, set that equal to 0, just take the x minus h itself, set it equal to 0, you would of course get x equals h. That will be the x-coordinate of your vertex, as x equals h, which was also your line of symmetry. And then that k is your y-coordinate of the vertex. So it literally gives you your x and y-coordinate of the vertex right here. And the x minus h also gives you your line of symmetry. So with the vertex form, actually you got your work cut out for you. So let's do some examples of that. Then there's one more form after this. So we have f of x equals x minus 1 squared plus 2. So we are given f of x equals the quantity of x minus 1 squared plus 2. Well, the coefficient on the x minus 1 squared term is positive 1. So for 1, it's going to open upward since it's positive, and there's no stretching or shrinking indicated. So let's go right to the vertex then. The vertex, if you just set that x minus 1 equal to 0, you'll end up getting x equals 1. And then literally, that 2 is your k, so the 1's your h, the 2 is your k. That 2 there, that plus 2 is your y-coordinate of the vertex. So literally, the vertex is 1, 2. Which means your line of symmetry is x equals 1. So this actually saves you some work from the general form, a little bit at least. Now, let's see. So let's plot our vertex at the point 1, 2. Yes, indeedy. There's your vertex. It opens upward. So let's take 2 points to the right and 2 points to the left of the line of symmetry and plot them to draw our parabola. So why don't we take f of 2? Alright, so what is 2 minus 1? That's 1 to the second power is still 1, plus 2 is going to give you 3. So you'll end up with the point 2, 3, which is going to go right there. And now let's put in f of 3. Alright, so what is 3 minus 1? That's 2. Raised to the second power is 4. Plus that 2 would actually give you 6. So you'll end up with the point 3, 6. So let's find 3, 6. So there's 3, 6. Now let's put in f of 0. We're going to go to the left of the line of symmetry. So 0 minus 1 is negative 1, raised to the second power is positive 1, then plus 2 would give you 3. So you'll end up getting the point 0, 3. And then for good measure, let's put in f of negative 1. So let's see, negative 1 minus 1 is negative 2. If you raise that to the second power, you actually get positive 4. Plus that 2 would give you 6. So you'll get the point negative 1, 6. So let's find negative 1, 6. And now we have sufficient points to plot this parabola. And there's your parabola with vertex at 1, 2, line of symmetry x equals 1. We'll do a couple more in the vertex form, then we'll go into intercept form. Okay, what if we had f of x equals negative of x minus 2, that quantity squared, minus 1. So f of x equals negative of the quantity of x minus 2 squared minus 1. So right away we notice the coefficient, that a on that x minus 2 squared term is a negative. We have a negative sign. So that means the parabola is going to actually open downward. Now, that doesn't change our vertex, though. The vertex is literally, you set that x minus 2 equal to 0, you'll get x equals 2. So you get the x-coordinate at 2, your y-coordinate is at negative 1. So your vertex can be found at 2, negative 1. So there's your vertex at 2, negative 1. Which means your line of symmetry is at x equals 2. It's always at the x-coordinate of your vertex. So the line of symmetry is at x equals 2. So now, in order to plot this, let's take 2 points on either side of the line of symmetry. So let's take f of 3, all right? F of 3. So 3 minus 2 is 1. 1 to the second power is 1, but you have to negate that. So you would get negative 1 minus that 1 would end up giving you negative 2. So you'll get the point 3, negative 2, which is going to put you right about there. Now, what if I put in f of 4? Put in 4 for my x-coordinate. 4 minus 2 is what? That's going to be 2 to the second power is 4, but I got to negate that. I'll end up getting negative 4, then minus 1 will give me negative 5. So I'll end up getting the point 4, negative 5, which will put me right here. Now let's go to the left of the vertex, the left of the line of symmetry. So let's put in f of 1. 1 minus 2 is negative 1, raised to the second power is positive 1, but then I got to negate that positive 1. That'll give me negative 1 minus that 1, which would give me negative 2. So I'll end up getting the point 1, negative 2, which would be right here. And then, of course, let's put in f of 0. Well, 0 minus 2 is negative 2 raised to the second power is positive 4, but I got to negate that 4. That would give me negative 4, then minus 1. Well, that would end up giving me negative 5, so I'll get the point 0, negative 5. So 0, negative 5 can be found there. Now I have sufficient points to plot my parabola. And there's my parabola with a vertex at 2, negative 1, line of symmetry at x equals 2, and all the other points. I think we'll do one more of these, then we'll move into intercept form. Move that a little bit. That's bugging me. There we go. That's a little better. Okay. Good one. So we have f of x equals negative 2 times the quantity of x plus 3 squared minus 4. Start with your coefficient on the for that a. The a is negative 2, which means since it's negative, it's going to open downward. The parabola would open downward. Now that doesn't change your vertex, however. The vertex is going to be still take your x plus 3, set that equal to 0, you get an x coordinate of negative 3, and then your y coordinate's that minus 4. So the vertex can be found at negative 3, negative 4. So there's your vertex. Now, your line of symmetry is going to be at x equals negative 3, the x-coordinate of your vertex. So the line of symmetry is at x equals negative 3. And then, what else do we have here? We want to find 2 points to the right and 2 points to the left of the line of symmetry. So let's go to the right. Let's put in f of negative 2. Alright? So if I take negative 2 for my x, negative 2 plus 3 is 1. 1 to the second power is 1. Times that negative 2 gives me negative 2 minus 4, well, that's going to put me at negative 6. So I'll end up getting the point negative 2, negative 6. Then let's put in f of negative 1. Alright, f of negative 1, so negative 1 plus 3, that's simply going to be 2 raised to the second power is 4. Yeah, 4 times that negative 2, which is negative 8, then minus that 4 would end up giving me negative 12. So I'll end up getting the point negative 1, negative 12. That's a big jump. 12, which will put me right about down there. And then, let's see, now let's go to the left of the vertex, to the left of the line of symmetry, put in negative 4. So f of negative 4, alright, so negative 4 plus 3 is negative 1, raised to the second power is positive 1, times negative 2 gives me negative 2, then minus 4 would end up giving me the negative 6, so I'd end up getting the point negative 4, negative 6. So that's going to go right there. A little further down, eh? And then put in f of negative 5. Alright, so negative 5 plus 3 is negative 2, raised to the second power is 4, times negative 2 is negative 8, minus 4, negative 12, so I'll end up getting the coordinate negative 5, negative 12. So now I have sufficient points to plot this parabola. And there's my wonderful parabola with vertex at negative 3, negative 4, line of symmetry at x equals negative 3. All right, let's talk about the intercept form. We also have an intercept form for a quadratic equation. So f of x equals a times your x minus p times your x minus q. So as you know, most, but not all, but most quadratic equations factor very nicely into very nice linear factors. But, well, they technically all factor, just not very nicely. But that a is still your coefficient anyway, and the same as the other two methods. If your a is positive, the parabola opens upward. If it's negative, it opens downward. Now, the x minus p, that's one x-intercept. The x-intercept, of course, is where the curve either touches or crosses the x-axis. Same with x minus q. Well, let's notice something here. If it's originally a quadratic equation, it can only break down into two linear factors, right? Meaning that each factor is to the first power. Alright, so these are your intercepts. So if a factor is raised to an odd power, the graph crosses at the x-intercept. X-intercept, rather. So notice, x minus p and x minus q are both raised to the first power. If it were raised also to the third power, to the fifth power, to the seventh power, anytime it's raised to an odd power, at that x-intercept, the graph will cross through those points. Now, let's say it was raised to the second power, the fourth power, the sixth power, what have you, to an even power. Graph touches but does not cross. So if these factors were raised to an even power, it would still touch the x-intercept. It would touch the x-axis at that point, which is enough to make it an x-intercept because it still touches, but it does not cross. How can you remember this? If you even touch. If you even touch. That's a way I'd remember this. This won't really deal so much in what we're doing now, but the next unit will be general polynomial functions in their graphs, where you're going to get various factors to even and odd powers. So this is a little preview of what's to come with even higher order equations. But if it's to an even power, which these are not, it would just touch the x-axis at the x-intercepts. But if it's to an odd, it crosses. So you can remember, if you even touch, that's how you would determine whether the graph crosses or just touches the x-axis at that point. So we'll do some examples here. Bring this down so I can see what the heck I'm doing. Alright, so we have f of x equals the quantity of x minus 2 times x minus 6. Right? X minus 2 times x minus 6. Well, what we have here is the intercept form. The coefficient in front of those two products is 1, right? It's a positive 1, so the parabola is going to open upward. This here gives you your x-intercepts. So the x-intercepts, you just take each of these factors, set them equal to 0. Those are also called the zeros of your function, are the x-intercepts, are the same thing. X minus 2 equals 0, well, that would just give you 2, 0. Because x-intercept is when y equals 0. Then that x minus 6 is also, set that equal to 0, you would get the 0.60. So your x-intercepts can be found at 2, 0 and at 6, 0. So there's your x-intercepts. Now notice, each of these factors is raised to the first power. It's an odd power, so the graph is going to cross through the x-axis at those points. How would you find the vertex? How would we find the vertex? Remember good old FOIL from Algebra 1. Let's take x minus 2 times x minus 6, right? The good old FOIL. So you'll have x squared minus 6x minus 2x plus 12. The first, outer, inner, last term. I'm just doing this briefly because by now everyone should be comfortable with foiling the product of two factors. So you would get x squared first plus the product of your outer, so x times negative 6, plus the product of your inner, negative 2 times x, plus the product of your last, negative 2 times negative 6 plus 12. You would then end up getting x squared minus 8x plus 12. So there, in fact, is the standard general form of the equation. Now, to find your vertex, you'll take the negative of your b. Well, your b is negative 8, so negative 8 is positive 8 over 2 times your a coefficient, which is 1. So it'd be 8 over 2. You would have x equals 4. Then just put in f of 4. All right, so what is 4 minus 2? That's going to be 2. Times 4 minus 6 is negative 2. 2 times negative 2 is negative 4. So your vertex can be found at 4, negative 4. So there's your vertex at 4, negative 4. So now you got your vertex, you got your intercepts. You don't need to find other points. You can just plot a continuous curve through them. Whoa, I'm way off Keter there. Hold on a minute. So with the intercept form of an equation, you already got your intercepts, and then you just find the vertex. You use FOIL and find the vertex, then you can just draw your curve. You don't got to find additional points. It kind of makes it nice because you already have a point to the left and to the right of the line of symmetry. And of course your line of symmetry would end up being at x equals 4. Let's do a few more of these. All right, y equals the negative of x plus 3 times x plus 5. All right, so f of x equals negative of the quantity of x plus 3 times x plus 5. Notice the coefficient, that a term is a negative 1, which means the parabola is going to open downward. So we've established that. Now to find your x-intercepts, the x-intercepts, you just take each of your factors, set them equal to 0. X plus 3 equals 0 will give you x equals negative 3. So you'll have the point negative 3, 0 as an x-intercept. And then if you take x plus 5, set that equal to 0, you'll get x equals negative 5. So negative 5, 0 is yet another x-intercept, which will put that right there. Good, we've done that. Now let's FOIL this. So let's take the negative of x plus 3 times x plus 5. Let's leave that negative sign alone for a minute here. Let's just FOIL x plus 3 times x plus 5. You'll get x squared plus 5x plus 3x plus 15, which would give you the negative of x squared plus 8x plus 15. So to end up in standard form, you would end up with negative x squared minus 8x minus 15. So to find the vertex, you got to FOIL this if it's an intercept form to get it into standard form. Because your vertex is going to be the negative of b. Your b is -8. So negative -8 is +8 over 2 times your a. Your a is -1. So you'll end up having 8 over -2, which would be -4. Now just take f of -4 to find the y-coordinate. -4 plus 3 is going to be -1, so you'll have negative of -1 times -4 plus 5 is +1. -1 is 1 times 1 is 1. So you get your vertex at the point -4, +1. Which, that means your line of symmetry is through the point x equals -4. So there's your vertex. You got enough points now to plot this parabola. So by foiling and figuring out each of these zeros here, you got your parabola, and with the coefficient you figured it opens downward. And since each of these are to an odd power, they cross the x-axis at the x-intercept. Now the next two examples I'm going to do are going to be slightly different. You're going to see just how different. Alright, so let's say I had f of x equals x minus 1 to the second power. Just plain old f of x equals x minus 1 to the second power. Well, you could argue it's in both vertex form and an intercept form. Why is that? So vertex form is pretty easy to see. Your vertex, of course, you just set that x minus 1 equal to 0. You'll get x equals 1. You don't have a plus k term, so your vertex by default's at 1, 0. Easy enough, right? Now, that's your vertex, and it's also your x-intercept. If I wrote x minus 1 times the quantity of x minus 1, it's the same as x minus 1 to the second power, right? So that x minus 1 is also my x-intercept. The x-intercept is going to be at 1, 0. Well, notice this factor is raised to an even power. Remember, if you even touch. So here is going to be your 1, 0. It just touches there. So your graph is going to look something like this. Notice it touches the x-axis. It still touches it, making it an intercept, but it does not cross. It doesn't cross at all. It just touches the axis. That's what it does when a factor is raised to an even power. I got just one more example and we're done for the day. Let's say I had f of x equals -2 times x minus 3 squared. So I have f of x equals -2 times the quantity of x minus 3 squared. Well, let's start with your coefficient still. Your coefficient's negative, that a is negative, so it's going to open downward. Now, you can again argue this is in both vertex form and an intercept form all at the same time. Your vertex is a dead giveaway. Just take that x minus 3, set it equal to 0, you would get 3. You don't have a plus term, so it would just be 3, 0. Vertex is at 3, 0. And also, having said that, you just have the x minus 3 itself raised to the second power. So that means your x-intercept is also at 3, 0. And that x minus 3 is raised to an even power, raised to the second, so the graph is going to touch there but not cross at 3, 0. So here's your 3, 0, and since you have a negative coefficient, it's going to open downward. So it's going to look something like that. Notice it touches the x-axis but doesn't cross through it. So that's it for the basic graphs of quadratic functions. Next lesson, we're going to do a brief review of simplifying quadratic functions. So I hope everyone has a great day. And if you're in that heavy snow zone like I am, please stay safe, stay in if you can. Take care.